In this video, we're going to look at what's called function composition. So we have our four arithmetic operations, which we can use to combine functions and come up with this third function. But with functions in particular, there's a fifth one of these, a kind of a fifth operation, if you will, which is very natural and allows us to also create a new function. And this is called composition. So we'll add it on to the end here. We use the open circle to represent this operation. So we define function composition as this right here, and we call this f composed with x, or sorry, f composed with g rather, and this is equal to f of g of x. So g is replacing the x in f of x, right? So whatever your function f is, wherever there's an x, you're replacing it with g. So g of x is now the input of the function f. So you have your initial input x goes into g, which spits out the output g of x, right? Now this g of x, this output, this goes into f, and out comes f of g of x. Okay, so input goes into g, we call that output g of x. That output goes into f, we call that output f of g of x, and this is our new function. So we can do this with individual numbers, as we can kind of see here following this path, or we could do it with the entire function. So I kind of prefer this right-hand notation, just writing f of g of x. There is this open circle notation, as you can see here too, which is also very common, so they're both good to be aware of. So if we use these functions, x plus 3 and x squared minus 5x minus 6 for g, then what we're doing here is, if we're doing f of g of x, then we are really doing f of x squared minus 5x minus 6, because that's what g is. So everywhere that there's an x in the function f, we're going to replace with this entire expression for g. So f of g of x then is going to be x squared minus 5x minus 6 plus 3. Okay, so this x right here was just replaced by this entire expression. So we have this expression here where x used to be, so then we have the plus 3 because that's the only non-x term. And we could do this simple combining like terms, right? Minus 6 plus 3 will give us minus 3, and that's our new function, f of g of x. Now if we can do it the other way as well, g of f of x, this operation is not commutative, meaning that the order does matter. So addition and multiplication, those are commutative operations where the order you do them in doesn't matter. This is an example of a non-commutative operation where the order does matter. We're going to get a different answer potentially. Sometimes you might get the same answer, but it's just going to be coincidence. So here we're doing g of x plus 3, since that's what f of x is. So everywhere there is an x in g, we're going to replace it with all of x plus 3. So notice here there's an x that's being squared. So we're going to have x plus 3 being squared. Okay, so we're replacing that entire x term with x plus 3. And then there's a minus 5 times x. So now we're going to have minus 5 times x plus 3. Okay. So now we can go ahead and simplify this. X plus 3 squared is x plus 3 times x plus 3. We'll need the distributive property there. Minus 5 times x plus 3 minus 6. I alluded to the FOIL method. So if you have two binomials like this, if you want to quickly do the distributive property, what you can do is you can multiply the first terms together, multiply the outer terms together, multiply the inner terms together, and multiply the last terms together. So again, we're trying to make sure that everything in the first term is multiplied by everything in the second term. So there's two terms in both of these, so there's 4 total combinations. So we're just making sure, keeping track of all those combinations, making sure we get all of them. So this is referred to as FOIL though. So I'll just write this really small up here. Or you could just do it the long way and do the distributive property like we have been doing. So either way, x times x is x squared. 3 times x is 3x. X times 3 is also 3x. 3 times 3 is 9. And now on the second one, we have minus 5 times x, minus 5 times 3. So minus 5x, minus 15, and then we just have the minus 6 on the end. And then we can go ahead and combine any like terms that we might have. So we have x squared plus 6x. Actually, not just 6x, right? We have 3x, 3x, and minus 5x. So 3x plus 3x is 6x, but then we have minus 5x, so we'll just have x. And then we have 9 minus 15 minus 6. So that's going to be minus 12. All right, 9 minus 15 is minus 6. Minus another 6 is negative 12. So we get x squared plus x minus 12.